In this project, we are going to simulate the flow inside the aorta vein using the non-Newtonian pulsating blood flow. In this study, a non-Newtonian pulsating blood flow in aorta has been studied. UDF defines the pulsatile inlet velocity. A non-Newtonian fluid is a fluid that does not follow Newton's law of viscosity, i.e., constant viscosity independent of stress. In non-Newtonian fluids, viscosity can change when under force to either act more liquid or more solid. The geometry of the present project should be repaired before generating the mesh. Some powerful tools can assist us in fixing the geometry, such as the space claim, ICEM, and design modeler. In this study, we used ICEM to fix the geometry and to generate the mesh. First, the mesh was generated using the octree method and with 5 layers of prism mesh with ratio of 1.2. Second, the Delaunay method has been used to improve the quality of the existing mesh. The final number of mesh cells is equal to 457,864. Now the first step for you to start the simulation is to click on a fluid flow block and then drag it over a blank space in ANSYS Workbench software. Next, right-click on Mesh and then go over Import Mesh File. Then click on Browse and then select the mesh file that is sent to you with the rest of the files. Just like any other project, there are several assumptions taken into account for this project as well. The first assumption is that we have selected the pressure-based type for solver, which is because we are simulating incompressible flows. Second, we have selected absolute format for velocity formulation. And third, we have selected transient time study since we are simulating a time progressing phenomenon. Also, you can see here that we have enabled the gravity and its value is equal to minus 9.81 in z direction. Next, if you expand the model section and then double click on the viscous button, in the appeared window you will see we have selected laminar model to solve for our fluid equations. Now, to define the blood material for our project, we have to expand the materials and then right click on fluid and then select new. Now, in the appeared window, you either can define a new material by defining its properties yourself, or you can simply click on Fluent database and select your desired material from the list of available materials in the Fluent software.
You can buy this learning product to obtain a geometry file, mesh file, and a comprehensive training video on how to set up, meaning the pre-processing, solution, processing, and extracting results, which is the post-processing and analysis.
Now in this slide you can see we have extracted the pressure contour over the surface of the aorta vein. And finally, in this slide you can see the wall shear stress applied over the aorta vein surface in the final time step.